Dear students, application number 23. We need to find the resultant force on any one charge for the given equilateral triangle. I consider the equilateral triangle having the vertices A, B, C, and at vertices I place the charges Q, Q, Q. They are all similar charges, and they are at a distance of small a, small a, small a. We already know in equilateral triangle each angle should be 60 degrees. I want to find out net force at A because of these two charges. Because of B and C, how much amount of net force acting on A I want to find out. Further, take the charge Q from A to the B, then you will get repulsive force in the direction of FAB. Again, I will take the charge Q from A to C, then you will get again the repulsive force in AC direction, along AC, FAC. ఓకేనా, ఎందుకు ఇక్కడ క్యూని క్యూ దగ్గర తీసుకెళ్ళాలనుకోండి ఏమవుతుంది, రిపల్ అవుతుంది. లైక్ చార్జెస్ రిపల్ ఇచ్చేస్తారు కదా, ఏ డైరెక్షన్లో ఎఫ్సిఏ డైరెక్ట్ ఎఫ్ఏసి ఏ నుంచి సికి ఏవేగా యాక్ట్ అవుతుంది రిపల్సివ్ ఫోర్స్ కాబట్టి. నౌ బోత్ ద ఫోర్సెస్ మేకింగ్ యాంగిల్ 60 degrees. వై? బికాస్ వెర్టికల్లీ ఆపోజిట్ యాంగిల్స్ ఆర్ ఈక్వల్ కాబట్టి. సో బికాస్ ఆఫ్ ఎఫ్ఏసి అండ్ ఎఫ్ఏబి వీ నీడ్ టు ఫైండ్ అవుట్ నెట్ ఫోర్స్. సో నెట్ ఫోర్స్ ఫార్ములా ఫర్ ద టూ forces having theta angle between them form the root of f1 square plus f2 square plus 2f1 f2 cos theta. Here if you observe, f1 means FAB, f2 means FAC. f1 is nothing but kq square by a square, f2 also kq square by a square. Nothing but both are equal forces. So that's why you can take f1 as f, f2 also f. So root of f square plus 2f square, angle between the two forces you will get 60 degrees. So 2f square cos 60 1 by 2, 2 cancel, finally you will get root 3f. F means we already know f1 equal to f2 equal to kq square by a square. So that is the net force at point A because of two charges B and C. Coming to next application 24. Again I am taking the equilateral triangle A, and at A I am taking the negative charge minus q, and at B positive charge, at C positive charge. So distance will be same, A and A. Here I want to find out the net force at A. I think but because of negative charge, how much amount of force will exerted on negative charge because of B and C I want to find out. Further, take the negative charge towards B, you will get attractive force towards B, that is called FAB. Again take this negative charge towards C, then again you will get attractive force between the minus q and plus q along AC. Nothing but if you observe those two forces FAB, FAC, the angle between them is 60 degrees. Why? Because you have equilateral triangle. So we need to find a net force at point A. So nothing but we can apply the formula root of f1 square plus f2 square plus 2f1 f2 cos theta. Again theta means 60. Both are similar forces. Nothing but FAB equal to FAC equal to F. So finally you will get root 3f. Like in the previous case what we got, same thing you will get root 3f. Root 3 into kq square by a square. Why? Because two charges kq square by distance between the charges is a square you will come. So that is about 24. Coming to application 25. I am taking here isosceles right angle triangle. Isosceles right angle triangle. Nothing but two sides are equal and having the angle 90 degrees for the triangle. That is nothing but isosceles right angle triangle. So here these two angles will be 45 degrees. And this angle will be 45 degrees. Why? Because in any triangle sum of three angles equal to 180, but both are equal sides. Equal sides having equal angles are in opposite according to triangle properties. So I want to find out net force at A. At A I want to find out net force. Now for that, from A take the positive charge towards B, then you will get repulsive force. Positive repulsive each other in the along AB direction. Like this you need to represent. And from A take positive charge towards C, again you will get repulsive force towards A, nothing but away from the A, like this. Now you can observe the angle between the FAC and the FAB 90 degrees. Now I want to find out the net force between the FAC and FAB, but both are equal values, nothing but kq square by a square to kq square by a square. So this is F and this one also F. So finally you will get F net force equal to root of FAC square plus FAB square plus 2 cos A cos 2 f1 f2 cos 90. Cos 90 0. So you will get like this. Both are similar forces, f square plus f square. You finally get root 2f. F means what? So you can apply the formula Coulomb's inverse square law formula kq square by a square. That is about application 25. Coming to application 26. Again I am taking the right angle isosceles triangle having the angles 90 degrees, 45 and also 45. Here I want to find out net force at point C, and I am placing the charges plus Q plus Q plus Q at vertices of the triangle. At C I want to find out net force. For that, take the charge at C towards B and take the charge towards A and find out the net force between them. You will get answer. So first case I am taking the plus Q charge towards B. So both are similar charges. You will get the repulsive force along BC direction, nothing but KQ square by, you already know this one A, this one A, this is nothing but root 2A. By applying the Pythagoras theorem, you will get hypotenuse square equal to side square plus side square. Hypotenuse value you will get root 2A. Finally, the force between the BC, you will get KQ square by 2A square. If I take KQ square by A square is F, KQ square by A square is F. So you will get F by 2. That is F2 I am taking. For CA, nothing but if I take the charge Q towards A, both are similar charges, you will get repulsive force away from the C. So you will get FCA formula KQ square by A square. KQ square by A square I already told you F I will take. Nothing but F1 means F, F2 means F by 2. Nothing but you are getting C like this. One will be FCA, one will be FCB. Nothing but for this at this point you will get the forces like this. One force like this, F1, and one force like this. Nothing but vertically opposite angles are equal. This one 45 means this one also 45 degrees. Nothing but here having the forces F1, F2, having the angle between them. To find the net force formula, root of F1 square plus F2 square plus 2F1 F2 cos theta. Theta means 45 degrees we need to take. By substituting F1 value F and F2 value F by 2, so you will get answer root of 5 by 4 plus 1 by root 2 into F. Coming to application number 27. Again I am taking the isosceles equilateral triangle only, and I am taking the Q0 charge at point B, at vertex B. I am taking the Q0 charge. At Q0 charge, because of Q0, how much amount of net force will act on A and C, I want to find out at point B. For that, if you observe, take this Q0 towards C. Q0 towards C is nothing but negative charge. So Q0 means positive charge. Both are attracting each other. You are getting the FBC along towards negative Q. Towards minus Q will get force. Coming to BA. In the BA direction, if you take the Q0 charge, so because of this similar charges, you will get repulsive force away from the B. You will get FBA direction as a force. Both are similar charges but having the sides A, so you will get and angle between them is 90 degrees. Finally net force you will get root 2F. So root 2 into K, here charges you need to take as Q0 and Q, magnitude values. So Q0 by A square is the net force because of this isosceles right angle triangle. This is the application about triangle cases.